Let's take a look at the ways by which rivers in an equilibrium condition moderate the extreme flow power and erosive energies created during flood events. Rivers develop bed armoring over time. This surface layer of the coarsest materials in the channel provides a degree of resistance to the erosive energies of the flow. In addition to an armor layer, rivers also develop bedforms, such as ripples and dunes in the flattest sandbed rivers, riffles and pools in the relatively flat valley bottom rivers with gravel beds, and steps and pools in steeper rivers with cobble and boulder bed materials. These undulating features of the bed serve to turn or roll the flow, creating turbulence, which we see as waves and whitewater. This turbulence is very important in dissipating or burning the energy and power of the flow, literally converting it to heat. Another most important means of energy dissipation in river systems, especially those relatively flat systems in the valley bottoms, is the spilling of flood flows onto the floodplain, where the erosive energy of the flow can spread out and be absorbed by the large surface area of the floodplain. In order for dissipation of energy through flooding to occur, it is important that rivers be well connected to their floodplains. In other words, the channel banks cannot be so high that they prevent large flows from spilling onto the floodplain. In humid mountainous regions such as Vermont, the banks of the river should be just high enough so that the average high spring flow just begins to spill onto the floodplain. Well-formed armor layers and bed forms and floodplain connectivity are critical in the moderation of extreme flow power and erosive energy and maintenance of river equilibrium.